Okay, let's move to the next question. This question asks us about the information that we can obtain from the phase diagram provided. So from the question already attach or give us this phase diagram of mixture of ethanol and water. So from the phase diagram, we can extract a lot of information from that. So first thing first, we know that from the phase diagram, we know that we have one isotropic point here. Point, and then we know that from this graph it is a deviate from ideal mixture. So what I mean by this, and then we know that the boiling point of this mixture is 78.2, and the boiling point of ethanol is 78.5. Okay, while the boiling point of water is 100 degrees centigrade. And here we know that this one is toward this one is ethanol, and toward this one is the fraction of water. So the maximum, we know that in a solution like this one, the solution, for example, if it's contained here, for example, for our ethanol and water, we have ethanol and water. So we can separate these two components by using this fractional distillation. So at a certain temperature, we can heat thermometer. We just provide the heat here. So we just manipulate with the heat. But at a certain temperature, here we can collect from the solution. It's depend on the temperature that we modify. For example, so here the maximum we can get is 95.6% of ethanol. So for example here, the statement is distilling a mixture of ethanol containing less than 95.6% of ethanol by mass lets you collect a distillate containing 95.6% of ethanol in the collecting flask and pure water in the distillation flask. Okay, so from the previous question, okay, we know that the boiling point, yeah, the boiling, so that the BP, boiling point of water is 100, while boiling point of ethanol is at 78.5. 78.5. Okay, so how to collect 95.6 here? How to collect? So we need to modify we need to play around with the temperature. So here, so if here is 78.2, 78.2, so if we provide heat and the temperature is the temperature of 78.2 and less, we can collect 95.6% of ethanol. in our distillate, while the remaining is water. While in this distillation flask, we will have 100% of pure water. So this is what is meant by this the phase diagram. So if we, let's say if provide more heat, if we give more heat, and maybe more than 100, so what will happen? So sorry, we give heat at least 78.2 and above. So 78.2 and above. So here what we get: distilling a mixture of ethanol containing more than 95.6 of ethanol by mass. Let's collect is a distillate containing 95.6% of ethanol in the collecting flask. So pure ethanol in the distillation flask. That is what will happen. So here is how we read this graph. And then for next question, stated that the boiling point of benzene is 80 degrees centigrade, whereas ethanol is at 78.5 degrees centigrade, and azeotropic mixture of benzene ethanol contains 32.4% of ethanol given the boiling point of 68.9 degrees centigrade. Sketch. The question asks us to sketch and label the boiling point composition curve of this solution, and what would be in the distillation and collection flask when the fractional distillation is carried out for a solution containing 50% of ethanol. So first we need to sketch this graph. We have one x-axis and two y-axis, and then this indicates ethanol, and this one is benzene. Here is the mole fraction. Towards this one is mole fraction of benzene from 0 to 100. So we sketch the boiling point of benzene. The boiling point of benzene is 80. So if it's benzene, so it will be like, if here will be benzene, where the ethanol is 78.5. Sorry, here is the ethanol. So I sketch this one. So say that an azeotropic mixture of benzene ethanol contains 2.4% ethanol. Give the boiling point of 68.9 degrees Celsius. So here is our azeotropic point. So from there we can sketch our diagram. So it will be look like this. And then question asks us about what will be in the distillation and collection flask when the fractional distillation is carried out for a solution containing 50% of ethanol. So maybe here 50% is like this. Here we know that this one is 2.4%. So here is 50%. So when we sketch, so we get this kind of graph. So from there we can determine that our collection flask will containing 2.4% ethanol, and our distillation flask will have a pure ethanol. So here how we read this kind of graph, how we answer this kind of question. So it means that, so from there, it means that what will be in the decision and collection flux when the fractional decision is carried out for a solution containing 50% of ethanol. So it's been, so what we get is you will have 2.4% of ethanol, and the remaining will be feed. The remaining will be benzene. Okay, and we have 100% benzene. And then here we have 100% of ethanol. Yeah. And then let's move to the next question. Phenol and water show partial miscibility. When we talk about this one is keyword partial miscibility below 64 degrees centigrade. The critical concentration at the upper critical temperature is S equal to 0.3, where S is the mole fraction of phenol at 50 degrees centigrade. The two solutions in equilibrium have S equal to 0.24 and S equal to 0.48, and at 45.5 degrees centigrade, S equal to 0.22 and S equal to 0.51. Sketch and label the liquid phase diagram. So here is our TUC. So here we have a water and phenol, and then here is our TUC, and we can sketch 0.22. Okay, the critical point when it is 0.3, and then where S is the mole fraction of phenol at 50 degree. Okay, 50 degree. Okay. Two solution have this one S.22, and the one is we plot it, and it will be 0.48, and at 45.5 degrees centigrade, S equal to 0.22 and S equal to 0. So again, when we plot this one, we have, so it means that above the TUC we have liquid in one phase. However, in this region we have two liquid phase because it is a partial miscible. When partial miscible is means that in one container at a certain temperature and pressure, at certain temperature we can see the two distinguished layer. However, when we give heat or provide heat according to temperature that will change, and then this one will be miscible. So we doesn't have two distinguished layer anymore. It's depend on the temperature. That is mean by partial miscibility. And then so from there we can sketch the kind of diagram, and then this is the diagram will looks like.